Today, we're going to do 5.6, the trigonometry of right triangles. Remember, I told you when we were working on the unit circle that the sine is always the y value. Now notice if the hypotenuse was 1, then it would just be the y value. I'll call this y and I'll call this x. So it would just be y over 1, which is the same as y. But now we're talking about right triangles outside of the unit circle where the hypotenuse could be anything. So in that case, we want to say the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. And then the co-functions are all reciprocals. I know a lot of you learned SOHCAHTOA. If you learn SOHCAHTOA and you want to use it, it means sine is the opposite over the hypotenuse, cosine is adjacent over the hypotenuse, and tangent is the opposite over the adjacent. Given that the sine of theta equals 4/7, find the value of the remaining trig functions. So the best thing to do here is just draw a right triangle. And here's theta. And the sine is the opposite over the hypotenuse. How do I find out, let's just call this A. How do I find A?
The Pythagorean theorem?
Exactly, perfect. So I know that A squared plus 4 squared equals 7 squared. Or I have A squared equals 49 minus 16, which is equal to 33. So A equals the square root of 33. Okay, and now it says find the remaining trig functions. What they're basically asking is, what is the cosine of theta? What is the tangent of theta? Here, I'll just write sine here. And then here's my reciprocal functions, cosecant, secant, and cotangent of theta. So my sine of theta, we already know, is 4/7. What's the cosine of theta?
Radical 33 over 7.
Perfect. The adjacent, so adjacent means next to, so this is the line next to the angle, and hold on. And, oh wait, that wasn't where I wanted to be. And this is the line opposite theta. Does everybody see why it's opposite and why it's adjacent, right? I guess that's a yes. Okay. And then what we want to do next is we want to say, what's the tangent? So what's the tangent? The tangent is the opposite over the adjacent. Or we could say it's sine over cosine, whichever you'd like. So the opposite over the adjacent is what?
4 over radical 33.
Good. Now, I'm not sure. Actually, Alex makes you rationalize things at the beginning, and then they stop making you rationalize. I'm not sure if you have to rationalize for these problems or not. But if you do, you're going to multiply this by the square root of 33 over the square root of 33, which equals 4 times the square root of 33 over 38. Either one of these answers is fine with me. Make sure that's fine with Alex. Okay, and then for the cosecant, all we do is we flip the fractions. So we have, for the cosecant of theta, it's 7 over 4. For the cosine, it's 7 over the square root of 33. And for the tangent, it's the square root of 33 over 4. Does everybody see where I get those numbers from? If you have a question, feel free to ask. I'm perfectly fine with that. Okay, no questions. On we go. All right, so now it says solve the given triangle. How can I solve this triangle? I'm positive that C is not 1 because we already know that that y value, or that opposite, is 17.9, c has to be bigger than that, right? So
Using
how
law
would I,
signs.
excuse me?
Law signs.
We don't know the law of sines.
Oh, all right.
You could do like sine of 30 is
Good.
equal to 17.9 over c.
Exactly. So the sine of 30 degrees is equal to the opposite over the hypotenuse. Okay? Now, what's the sine of 30 degrees?
Is it a half?
Like
One half.
you guys are going to have to get really quick with these things, especially if they're in the first quadrant, because then you don't have to think reference angles. You should know those values by heart. So what did you say it was?
Over H.
One
eight.
over 2.
What is the sine of 30?
It's a half, right?
It's a half.
Yeah,
Good.
half.
Yeah, I just couldn't, no, I didn't hear anybody say it, but yes, it's 1/2. So now I know this. So I know C is equal to 17.9 times 2, which is 35.8, I believe. And now I know my hypotenuse, right? And then how would I find B?
Pythagorean theorem.
I could use the Pythagorean theorem, but how would I find B without a calculator? Because I don't really want to square 17.9 or 35.8 and take
Tangent
this.
of 30.
Hmm?
Tangent of 30 is equal to 17.9 over b.
I could do that. That's probably a little harder because do you know what the tangent of 30 degrees is offhand?
2 square root of 3 over 3.
Yeah, but there's an easier way because we know the sine, isn't the cosine going to be the adjacent over the hypotenuse? Right?
Mm-hmm.
So that, I think this is an easier way because most people won't know the tangent offhand. They'll know the sine and cosine because those are my 2 points, right? You see what I'm saying? Does everybody see what I'm saying?
Yes.
I think so.
Okay. And the cosine of 30, I'm sorry, is the square root of 3 over 2. So that's equal to b over 35.8. So that means b is going to equal to 35.8 times the square root of 3 over 2, which in our case without a calculator is a fine answer. This would be a calculator problem. Well, this wouldn't be a problem in ALEKS where they had these weird numbers, honestly. Okay. Is there any question about this? So now we know what A, B, and C are. Okay. Okay, so now we have something called the complementary angle